how to bridge the gap between those two. So we have some new formulas here, and we'll explain where those come from. Sine theta is going to be equal to y over r. Cosine theta will be equal to x over r, and tangent theta y over x. And then, of course, we have our inverses here. Not inverses, but our reciprocals here. Well, where does that come from? Well, notice here we have an example of an angle theta opening up, and here is its terminal side. All right, it stops at a point x comma y. Now notice we are used to using triangles, and if we were to draw a line straight down here and straight over, where do we get the point x comma y? Where do we get those coordinates? Well, x is the horizontal distance from 0, 0, right? We've gone x in this direction. So we know that the length of this side of the triangle would be x, okay? And y is our vertical distance from 0, 0. So we went to the left x and up y. So this would be a distance of y. So we're really still dealing with a right triangle, but we're viewing it as a circle. Okay, so now we're going to transition here into using the point x, y to find our sines, our cosines, and our tangents rather than having this triangle drawn out for us. Okay, so it makes sense that sine would be y over r, right? Because if this is our angle, theta, okay, sine is equal to opposite over hypotenuse. Well, the opposite side is y, the hypotenuse is r. Cosine is adjacent, here's our adjacent side, over the hypotenuse, so x over r, and tangent is opposite over adjacent, so y over x, right? And then we could find these in the same way. Well, the most important thing that we're going to need to know as we move to a unit circle is that x is our cosine, and y helps us determine our sine. Now, a lot of times when we memorize sine, cosine, tangent, we memorize them in that order, sine first, cosine second. So make sure you don't mix up. Sometimes people mix it up for that reason and think that sine is x and cosine is y. Cosine is our x value, sine is our y value for a point on the unit circle. Okay, so let's go ahead and transition that to the unit circle. Ignore this extra circle here. Okay, we are going, like I said, to a unit circle. Well, what does that mean? Well, to be a unit circle, that means the radius of your circle is 1. So going back here, let's take a look. What would happen if our unit circle was 1? Okay, if this radius has a length of 1, well, then our sine is y over 1, which just equals y. Our cosine is x over 1, which just equals x. And tangent didn't have the radius involved anyways. Okay, so as we move to the unit circle, we don't have to worry about our r, because in a unit circle, the radius is always 1. So let's look at some of the values on this unit circle. If you've been working on memorizing your exact values for sine and cosine of these standard angles that we use, 30, 45, 60, and 90, you'll recognize some of these, right? So notice if we have a 30-degree angle, if we have memorized the exact values, or if you haven't, look back at your notes. This is supposed to be cosine, right? Our x value of our point is cosine, the y value is our sine. Okay, so here's the keys you want to remember when working on the unit circle. It's the point xy, the cosine is the x value, the sine is the y value. To find tangent, we take y over x. So looking at this, again, if we've memorized 30 degrees, the cosine of 30 degrees is the square root of 3 over 2, and the exact value for the sine of 30 degrees is 1/2. Now, if you memorize the values on this unit circle, to find tangent, then you would just have to go y over x, or sine over cosine. Okay, we would then invert and multiply like we do with fractions. And we get that the tangent is 1 over the square root of 3. And if we want, we could simplify that and not have the root in the bottom, and we would get the square root of 3 over 3. Okay, so that's why the unit circle is helpful. We can memorize these values all the way around, and then it helps us to find values no matter how many times we've gone around the circle. Now I want you to notice something. Notice here we have a cosine root 3 over 2 sine 1/2, and it happens again here. The values are almost exactly the same. Okay, that is because the reference angle here is 30 degrees. So anywhere we are 30 degrees away from the x-axis, we will have the same sine and cosine, almost, okay? Not quite. There is one difference. And if you look at those, can you spot the one difference that they have between one another? Here we have root 3 over 2 and 1/2. Here we have negative root 3 over 2 and 1/2. Here we have negative root 3 over 2 and negative 1/2. And here we have positive root 3 over 2 and negative 1/2. The only thing that's changing is whether sine and cosine are positive or negative. Okay, so notice in this quadrant, sine and cosine are both positive and negative. And if you think of them as graphing a point, we know that cosine is x and sine is y. The reason that all of these values are positive in the first quadrant is because if we are graphing a point in the first quadrant, the x value is positive and the y value is positive. Okay, so that's how we end up with sine and cosine both being positive in this quadrant. In the second quadrant, our points, we have to go from 0, 0 to the left and up. So that makes our x values of our points negative. The y value is still positive. So then when we are in this quadrant, since our x values are negative, that means our cosines are negative. And our y values are still positive, so our sines are positive. The same numbers, just different signs. And it's important to note that they do have different signs. When we come down to quadrant 3, well, to graph a point in quadrant 3, you have to go to the left and down. Your x value is negative and your y value is negative. And so notice our sines and cosines will both be negative in this quadrant. And finally, if you come to quadrant 4, we would graph a point in quadrant 4 by going to the right and down. Okay, we're going to the right, so our x values or our cosines will be positive, but we're going down, so our y values or our sines in this quadrant will always be negative. Right? So again, notice these had exactly the same numbers for sine and cosine. The only difference was whether the number is positive and negative. And so that's why it's important to memorize these functions in quadrant one. And then as long as you know where sine, cosine, tangent are positive and negative, you will be able to do a lot of work by memorizing just a few details. So let's use this. The other thing you can do is memorize your chart. So here is a chart with our degrees and our radians, and then the values of sine, cosine, tangent, cotangent, secant, and cosecant. Okay, so be working with those so that you're memorizing them, because having them memorized is like having your addition and multiplication tables memorized. It makes it go much faster, and it's much easier to understand if you have those values memorized and at hand. So let's do some examples. All right. So here we're asked to list all angles. This means theta, so any angle between 0 and 360 degrees where the given value is true. Okay, so we want to know all places, all angles on the unit circle where the cosine of theta is equal to 1. Well, what does that mean? So here's a couple of ways you can do this. For cosine to be 1, what does that mean? Well, we are on a unit circle, so our x value has to be 1, and our y value would have to be 0. We go directly here. So the cosine is 1 at 0 degrees. A lot of times it happens twice on the unit circle, but notice the only other place will be a distance of 1 from the center is over here, and here it wouldn't be 1, right? It would be negative 1. Okay, so our only angle where cosine theta is 1 is at 0 degrees. The other way you could do that is to memorize those values, either by looking at the chart. Okay, so you go, okay, where is cosine 1? And we look down the line. The only place that the cosine is 1 is at the angle 0 degrees. Or you could use the unit circle. While you're memorizing, cosine, remember, is our x value, so where is the x value of the point 1? The only point here that has an x value of 1 is 0 degrees. Okay, so that's two different places you can find that information. And when I change pages, it's going to delete all my work. So here is 0 degrees. Let's move to the next one, cosine theta being 0. That means we have to have a point on the unit circle where x is 0. Okay, when is x going to be 0? Well, if x is 0, that means you haven't gone to the left or to the right at all. You've just gone straight up or straight down. All right, well, on the unit circle, where would that happen? Well, that would happen here and here at the point 0, 1 and at the point 0, negative 1. Those are the two places on the unit circle where x is 0 or the cosine is 0. What angles do we have there? Well, this angle is 90 degrees, so that's our first answer. And the angle opening down here is 270 degrees. Okay, so those are my two angles between 0 and 360 where the cosine of theta is 0. So you can do it this way by putting the unit circle and saying, okay, where would x or my cosine be 0? Again, the other option you have is to use your chart for now. Eventually you need to have it memorized, but on the chart, say, okay, where would I have a cosine of 0? Here. Okay, so when my angle is 90 degrees. And are there any others? Yes, here, when it's 270. So my two answers were 90 and 270. You could also use your unit circle chart. Again, just looking around, we want a cosine of 0, so we want all of the points, keeps going back and forth, all of the points where x is 0. So we would go around x is 0 here at 90 degrees, and x is 0 here at 270, which is basically what we did at the beginning, but without the chart. Okay, so far our answers have been 0 degrees for this first one. The second one we found 90 degrees and 270 degrees. Next, where is the sine of theta equal to 1/2? Now, if you have your trig values memorized already, you might know where that happens in the first quadrant. Okay? If you don't, go to your charts. Okay? Where is the sine equal to 1/2? Well, the sine of 1/2 is equal to 1/2 at 30 degrees. And if you continue down, it's also at 150 degrees. If you were to use the unit circle, sines are y values, so we want the points where the y value is 1/2. So that would happen here and here. Notice down here I have a y value of negative 1/2, but that's not going to work. We want positive 1/2. Okay, so again, that happened at 30 degrees and 150. Now, again, we're working towards having these values memorized. And so here's what we do if we have our values memorized. I would have memorized that the sine is 1/2 at 30 degrees. Okay, so I know one of my answers is 30 degrees. Then I have to use what I know about reference angles and where sine and cosine are positive or negative. So I know that I will have similar values everywhere that the angle is 30 degrees away from the x-axis. All of these angles have similar values for sine. The only difference is sometimes they're negative instead of positive. So my next bit of information would be, okay, which of these angles is the sine positive? Well, we know sine and y values, so we know that these two are negative because y is negative below the x-axis. So it would have to be this angle here. Okay, would have a sine of positive 1/2. And what angle would that be? Well, it's 1 180 minus 30. It is 30 degrees away from 180 degrees, which gives me 150. Now I know looking at a chart and finding the numbers looks way easier than this, but eventually we're going to have much longer drawn out problems, and, and you will want to be able to know those values and be able to find them. You also may have to find it for values that are not exactly 30, 45, 60, or 90. Okay? Let's try the next one. This one we want to know sine of theta is negative 1/2. Well, we could look at our chart. If you want to go ahead and do that and know what we're going to come up with, you can. Let's try this method. Okay, we already discovered that sine is 1/2 at 30 degrees. Where would sine be negative 1/2? Well, it would be on these other two options, right? We know that the sine of 30 is 1/2, okay, but we want to know where that would be a negative value instead of positive, and it would be below the x-axis here. So I can easily find those by saying, okay, I know sine is positive 1/2 at 30, so I know these two places where sine is negative, and this would be 180 plus 30, which is 210, so I know at 210 degrees I would have a sine of negative 1/2, and here as well. This would be 360, so 30 less than 360 would be 330. So I know the two places where the sine of theta is negative 1/2 are at 210 degrees and 330 degrees, not at 30 or 150 because the sine is positive 1/2 there. And we can check our answers with our chart. Okay, where is sine negative 1/2? Right here, which was 210. And right here, which was 330, just like we discovered. You can do the same with your unit circle. Where is it negative 1/2? Where is the y value negative 1/2? Here at 210, and again here at 330. All right, one more problem. We've answered all the problems above. Where is the tangent equal to the square root of 3? Well, if you have memorized your values, you would know where that is, right? If you haven't, then you can refer to the chart, okay? But we should know that that happens at 60 degrees, okay? Tangent is root 3 at 60 degrees. Okay, so here's my 60-degree angle. We know those values will be repeated every quadrant where it's 60 degrees away from the x-axis. So here and here and here. Okay? But we want the ones that match, so we want the ones where there is a positive tangent. Well, we know tangent is positive in the first quadrant because everything is positive in the first quadrant. So we know that 60 degrees is one of our angles. Where is the other place that tangent is positive? Okay, well, tangent is negative here, and the reason for that is because our sines are positive and our cosines are negative. So for tangent, which was y over x, we get positive over a negative, which is a negative. Here, x and y are both negative, so if we divide them, a negative divided by negative is a positive. So again, two things to memorize are the exact values and where sine, cosine, and tangent are positive and negative. And they will come in very handy because we know tangent is positive in this quadrant, so we know that our other angle that would have a tangent of positive square root 3 is the angle that's 60 degrees away from the x-axis in quadrant 3. To find that, it's 60 degrees past 180, or 240. Okay, what about quadrant 4? Would that work? Well, no, it wouldn't, because in quadrant 4 the y values are negative and the x values are positive, so when we find our tangent by doing y divided by x, we get a negative value. Let's check our answers with the chart. 60 and 240, is that correct for a tangent of square root 3? So here's our tangents. Square root 3 at 60, perfect. And where else is it just plain square root 3 at 240? So we